Hello class, welcome back. This section we're going to be looking at probability with combinations and permutations. And these are two new things that maybe you guys have seen before, maybe you haven't, but it's a pretty interesting topic. Alright, so we're going to talk about what these things are. First one is a permutation. A permutation is an arrangement of objects when order is important. That's really important to understand, is that order matters with permutations. Okay, so on the screen here you see four shapes. This is one way to arrange those four shapes. Okay? Now what I could do is I could take and move these to look like this. It's the same four shapes, but it's a different order, so it's a second way that you can order these things. Now I take these and I arrange them again, something like that. That is now a different order, and that's another option. Okay? I could switch these two, and now this is another option. I could go back and put them like this, and this is another option. Okay, so every one of these is considered different because the order has changed. And in permutations, order matters. Now what we've got is we've got something called a factorial. Now a factorial is when you take a number, and it's this little exclamation point here you see on the screen. You take a number and you multiply by every number down to 1. Okay, so you see this n factorial equals n times n minus 1 times n minus 2. Think of it as, 5 factorial. Well, 5 factorial would be 5 times 5 minus 1, which is 4, times 5 minus 2, which is 3, times, and that pattern continues, 2 times 1 all the way down. You multiply all of those together, so 5 times 4 times 3 times 2 times 1 is 120, and there's your answer. Right, so that's what factorials are. All right, so what this does is allows us to use this formula for permutations. So a formula for permutations of n objects taken r at a time. And now that may look a little confusing, but n objects is just the total. So n is always the total. So how many things are you actually working with? The r is how many things you're using. So if I have 10 items and I'm using all 10, it would be 10p10. Okay? If it was I had 15 items and I'm only using 4 of them, it'd be 15p4. Right? But the formula is n factorial over n minus r factorial. Right? And then you simplify from there. And I'm going to show you a couple examples where you simplify. But it's important to understand what they're talking about. So here we go. An ID card has a number made up of 4 digits ranging from 0 to 9, and digits cannot be repeated. How many different ID cards can be created? And then what is the probability of choosing the ID card with the number 5613? All right, so 2 parts to this. How many different ID cards can be created? Well, ID cards, like it says here, have 4 numbers ranging from 0 to 9. So how many numbers are we choosing from? Well, from 0 to 9, there are 10 different numbers possible. So that would equal your n. We are going to be using 4 of them, so that equals your r. So that would be 10p4. Now the way that this formula sets up is you have n factorial. Well, n is 10, so 10 factorial, over n minus r, which is 10 minus 4 factorial, or 10 factorial over 6 factorial. Now from here you've got a couple different ways to do this. In maybe one of our online sessions, our chat sessions, or maybe a little later here, I'll show you how to do this in the calculator, but it's a good idea to understand what this is talking about. So 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Now hopefully you guys can see what's going to happen here. This is a fraction, and fractions that have the same thing in the numerator and denominator have those cancel out. They reduce down to 1 in every case. So all of those cancel. So what you're left with is 10 times 9 times 8 times 7. All right, so we take that 10 times 9 times 8 times 7, and you end up with 5,040 different possible ID cards. Now that's the first part. Okay, the second part says what's the probability of choosing a card with 5613 is the number. Well, probability is the number of outcomes that you want over the total number of outcomes. Well, we want this one. Okay, if order matters, how many cards have 5613? Hopefully only 1. Okay, so the number you'd want would be 1, out of the total number, well, we found that. It's 5,040. So your probability is 1 out of 5,040, and there's your final answer. All right, let's take a look at this second one. All right, Ron, Mike, and Sue are among 12 people who enter a race. What is the probability they finish first, second, and third based on the alphabetical order of their names? So they basically have to finish in the order Mike, Ron, and Sue. All right, well, first off, we've got to figure out how many different ways can these outcomes occur. Start by asking yourself, how many people do I have total? Well, that would be 12. So it's going to be 12. I want to know based on a specific order, first, second, third, so that means it's a permutation. And we want to take 3 of them, okay, because they're finishing first, second, and third. So it's going to be 12p3. So 12p3 sets up like this. N factorial over n minus r factorial. So that's 12 factorial over 9 factorial. Now, using the same logic we had in the last example, I'm going to stop right there in my numerator, because now my 9 factorial in the numerator and the denominator cancel. So what I'm left with is 12 times 11 times 10, which gives you 1,320. Oops. 1,320. Now, because we're asked probability, it's the number of things we want to have happen over the number of, or the total number of things. Well, we know the total is 1,320. The number of things we want to have happen. Probability they finish first, second, third based on the alphabetical order of their names. Well, there's really only one way to do this. It's Mike, Ron, Sue. So it's 1 out of 1,320, and there's your final answer. All right, so that's permutations. Hopefully that makes some sense. Now, the second possibility here is what's called a combination. So combination is an arrangement of objects when the order is not important. Okay, so the order doesn't matter here. If we go back up and look at these figures again, here's one order. If I switch these two, whoops, erase that. If I switch these two, the order has changed, but it's the same 4 objects, so it's not a different order. If I move this one, it's the same 4 objects. It's not different. If I move this one, it's the same 4 objects. It's not different. Okay, so the order, if it's the same or different from what it was, but all the same objects are there, that's considered a combination. Now, we have a formula that's pretty similar to the permutation one. Okay, so there's a formula to solve, oops, I should say combinations. I apologize for that. That's combinations. So there's a formula used to solve combinations of n objects taken r at a time, and it's this formula here. So NCR equals n factorial over r factorial times n minus r factorial. So it's pretty similar, except for we just add this additional r factorial in there. And what that does is it accommodates for the repetition of groupings. Okay? So let's see when this is important. So Brian is inviting 6 of his 20 friends to his birthday party at random. How many ways can he invite these friends? So there's your first question. And then what is the probability that those friends are Tony, Mike, Fred, Bobby, George, and Frank? All right, so we've got 6 of his 20 friends. The n would be 20, because that's always the total. It's the larger number. And the 6 would be r, because that's how many we're choosing from. Now, the important thing here is it's at random. We don't care what order he chooses them. He's just going to pick 6 people of the 20. So this would set up as 20C6. Now, for the formula, you set that up as n factorial, which is 20 factorial, over r factorial, which is 6 factorial, and then 20 minus 6 factorial. Okay, so that leaves you with 20 factorial over 14 factorial, 6 factorial. All right, from here, you can use some of that same logic we did before. Now I'm going to go 20 times 19 times 18 times 17 times 16 times 15 times 14 factorial. I'm going to stop right there because in my denominator I have a 14 factorial. And then I still have a 6 times 5 times 4 times 3 times 2 times 1. Okay, so don't forget you have both parts. So this 14 cancel out. All right, now we see what we have left. Well, in the numerator, I've got 20 times 19 times 18 times 17 times 16 times 15, which works out to be, see, 27,907,200. In the denominator, I have 6 times 5 times 4 times 3 times 2 times 1, which is basically 6 factorial, which is 720. Okay, so I've got that. Now I divide, and I end up with 38,760. So there are 38,760 different ways he could choose 6 of his friends. Now the question asks, what's the probability that those friends are Tony, Mike, Fred, Bobby, George, and Frank? So I need to know those exact 6. Well, there's only one way to choose those 6 people out of the 38,760 that he has to choose from. And so there's your probability. All right. Hopefully this is making some sense. It does take a little bit of a different train of thought. But you're always looking for the total. Okay, your total is your denominator every time. And then you just go through the numerator based on the probabilities. All right. Final one. I want you guys to pause the video and try this one yourself. Okay, hopefully you guys had enough time to work through this. So it says a set of alphabet magnets are placed in a bag. If 5 of those magnets are drawn at random, what is the probability they are the vowels A, E, I, O, U? All right, so start with your NCR. This is drawn at random. NCR. We know that there's 26 letters, and we are selecting 5 of them. So that's 26 factorial over 5 factorial. 26 minus 5, which is 21 factorial. So I got 26 times 25 times 24 times 23 times 22 times 21 factorial. In the denominator, I have 21 factorial, and then 5, 4, 3, 2, 1. Okay, so let's multiply. The 21s we know cancel. We got 26 times 25 times 24 times 23 times 22, which is 7,893,600. In the denominator, you have 5 factorial, which is 120. You take that, divide it out, and there are 65,780 ways you could choose 5 letters from the alphabet. Now, what is the probability that they are A, E, I, O, U? Well, there's only one way to get A, E, I, O, U, and it's to pull them all out. So it's 1 out of 65,780. And there you go. Okay, hopefully that made some sense. I'm happy to answer any questions. If you have them, please contact me. Don't hesitate. I want to make sure you understand what you're doing. And good luck. I'll talk to you soon.